Hey guys, so today we're finally unveiling the world's nicest little shed. So why do we build this?
And why is it so nice?
It's true. So a couple reasons. First of all, we need a little structure, not too big, about 10 by 10, to house our well pump controller and a bunch of other water treatment equipment that we have. So that's a good reason to build a little structure for it. And secondly, we need it, like a good engineer, we have to have a little building to act as a proof of concept to test out the building materials that we chose, both for the design and for fire safety reasons. So for this little building, you can see that the exterior is all Class A fire safety rating materials. And also on the inside, we did something a little bit different from most conventional houses to sort of test out our skills and our experience with it, and also to make sure that the structures we build on our land is completely fireproof.
Yeah, so before we go inside, I was gonna take you on a little photo tour of kind of some of the work we've been doing and how we built it. We started building it before we were filming everything, so like some of these other bonus features, we'll first go back in time, starting with some pictures. So starting with the foundation, like all buildings do, Sharon actually made this cool 3D model since we wanted to essentially have 3 different layers to the foundation. There's the layer that's the footings, which are the structural support that hold up the walls. Those are about 12 inches below grade. And then there's a level that has the kind of concrete skirt on 2 sides that's a little bit higher, and really kind of another level because it spreads out further than the walls themselves. And then we wanted the floor to be a few inches higher than that because we wanted to use this kind of brick ledge technique. But we wanted to pour all those 3 layers monolithically, meaning we wanted to do all of it as one pour. Since it's such a small area, if you do a little bit of concrete at a time, you get a short load fee. So the model helped us kind of outline how we wanted it to sit, since we got to pour it all at once and it all had to be formed at the same time. And it can kind of get dimensionally confusing with how to form something when you got to consider the thickness of the form itself. So it seems straightforward, but then you get outside to actually form it up and you're like, well, which end does this go on? Is it this side or that side? And if you get it wrong, you're off the thickness of the form, which is 1.5 inches. So anyway, the model was pretty cool. After we formed it up, we put rebar on 12-inch centers. You can see in this picture, Sharon really loves rebar. She really loves it, a lot of it. So it's probably overkill, but that's what we did anyway. And then about 1 truckload of concrete later, and 3 hours of pretty hard work, kind of feeling like we're going to pass out at the end, it was done. So after that, we did the metal framing, which was actually our first experience with it. We did actually a lot of research in advance since we hadn't done it before, and there's actually a lot to it that you have to know. There's, first you got to figure out some load calculations for the spacing and the size of frames to use. There's all this tables and information available, so we referenced that a lot and kind of really dug into the details on it, as well as some of the framing techniques. There's different ways you can make the framing members come together, different ways to attach them. It's all kind of prescriptive methods you can use to know you're doing it correctly, but there's also a lot of options. So we kind of did a lot of research in advance to figure all that out. And then the roof is kind of really too small to order a truss package, so we decided to create our own. We found this guy on the internet, it seemed good enough, he seems to know what he's doing. No, seriously though, the trusses were actually that we created are pretty cool. You really got to do some more angled cuts and extra pieces you have to add to the end and so forth, but at the end of the day they came out really strong. We load tested them with one Justin and decided that if I can hang on it and it doesn't move on just one of them, that it would be fine for the whole building. So after the framing was done, next up was the continuous insulation layer we wanted to have prior to the sheathing, which is a little unorthodox, but it would save us a step because we can attach the stone veneer directly to the sheathing. So it worked out okay, but this is probably something we'd do differently, where we'll actually put the sheathing on first, and the reason is that it actually gets a little bit hard to screw the sheathing through the insulation into the stud flange. You tend to miss it and you have to redo it a few times. So we did it intending to save some work, but in the end maybe it really didn't. So next time we'll do sheathing first and then insulation, but on this particular pump house we have insulation first. So after the sheathing, there was a air and water barrier that you need to have on all houses. On this one, we decided to use a liquid applied membrane. It's part of the stone system where the manufacturer of the stone recommends this particular type of membrane so that you have good adhesion and so forth. So there was that part under the stone, and then the roofing underlayment. And then on the inside, we did do an extra layer of insulation, about 1 inch of a spray-on polyiso on the inside, which kind of helps seal up some of the cracks and just gives you better R values on the walls and ceiling also. And so that brings us to the final layer, which you can see behind us. So it's got the stone veneer on the walls and the standing seam metal roof.
So if you're interested in any of the materials that we use on the pump house, we're going to be listing them in the description below.
All right, so let's go inside and check it out.
Knock, knock.
Who is it? Oh, hey, come on in. Check out our super cool pump house. Now, you can see behind me with all this amazing plumbing equipment, you're probably wondering, wow, what is all that awesomeness with these valves and pressure gauges? Well, you know, we can play submarine, but it actually serves more purposes than that. We'll get back to the plumbing in a second. Let's start over here with the electrical. So this is a 100 amp sub panel. We set this here. It's got this conduit, comes from the main panel you saw in the last video. So this gives us power in the building for lights and outlets and so forth. But the kind of main purpose was actually for this pump controller. So let's digress for a moment, get a little bit nerdy, talk about pressure pump systems. So like you've heard me mention a couple times, we went with the constant pressure system. If you have a well and you're going to put a pump in it, you really got two options. Your standard system, which would involve a bigger pressure tank, maybe like 40, 50 gallons, something like that. And the way those work is that the pump comes on, the submersible that you saw in the last video fills up the pressure tank, and then the pump shuts off. So at that point, the tank's pressurized about 60 pounds. Pressure bleeds down to about 40 pounds as you use the water, and then the pump kicks back on and fills it back up. So that's not constant pressure because, like I was just saying, the pressure is varying between 60 and 40 in kind of most systems. Constant pressure means there's this motor controller, which is a variable frequency drive. So rather than the pump just turning on and off, this turns the motor on at varying speeds to kind of meet the demand that you want. So it gives you a constant pressure. You can see right now we're at 65 pounds. If we ran some water, it would drop to about 60. And then the pump will kick on and it'll keep it kind of steady around 65 as you're using water. So this whole system was one of the main reasons to build the pump house, get it out from the outside, get it in here where it's protected from the weather. Okay, so moving on from electrical, let's talk about the plumbing now. Again, I hope you're interested in the nerdy details because that's what it's going to be. So this pipe is connected to the well head. Again, you saw that one in the last video. Comes out of the well about a foot or two underground, runs along underground up here into the building. So this is the entry point for the water. We've got a valve so we can shut it off right there if we need to. And then its first stop is this spin down filter. Spin down filter is kind of removes all the initial large particles, anything 50 microns or bigger, I believe, for this one. But it's called a spin down because I can go like this. And it kind of removes some of the particulates that have been collecting on this filter and flushes them away. So rather than having to replace the filter all the time, you can actually just do, kind of come in here and periodically clean out the larger particles. So anyway, it goes through the spin down filter. Next up is this constant pressure manifold. So you can see there is still a pressure tank. Like I mentioned, you know, it'll have about a 5 degree pound difference. So if you turn on the water just a little bit, it doesn't have to start the pump. You can use just a little bit of water, but the tank's a lot smaller. So then there's a pressure gauge, so you know what it's doing. There's this cool thing so that the pump controller knows what the pressure is. And there's a drain in case it overpressures. Anyway, a few different things associated with the manifold. If you get a constant pressure system, which we highly recommend because we love great showers, then all this stuff kind of comes as a kit and you plumb it together all the same. Coming out of this, we got a T for two different main uses of water. We'll talk about the irrigation first. So after we've transitioned, we come into some PEX piping, which was pretty cool. We learned how to use it on this job. which we haven't done before, but I love it. So coming to PEX, 1.25 inch, coming straight across through here is our irrigation water. So out of this valve so we can turn it off if we want. Then it goes through this high-tech looking gadget, which is a double check valve. It's a requirement for irrigation water to have a way to not backflow into the non-irrigation water, just for concerns about bacteria and so forth. Anyway, there's 2 check valves in here. Make sure the water doesn't get backed up. Comes through it, and then we tee it off and it goes to different valves. Then it goes out through the floor in different places for irrigating different parts of the property. Okay, so coming back from this tee, this side was going to irrigation, but if we go down this way, you can see the pipe changes, it's blue. That's because it's now 1 inch PEX. And from here is where it starts going through the treatment systems that we have for the domestic water usage that we're currently using when we're in the RV, and that we'll actually be able to use later inside the house too. So it comes into this pipe, then it goes through this 3-stage filter. Again, just removing particulates. So we've got this first one, anything 20 microns or bigger. Next one is 5 microns or bigger. You can see we've even labeled it. And then the last one is 0.5 microns or bigger. So by the time the water comes out of here, any particles left in it are super small. We got this little drain so that we can drain the pressure off if we've got to swap those filters out. And then the next stop it comes into is this system, which this tank is a part of. This tank's full of hydrogen peroxide. And what it does is as the water comes through this, it's detecting how much flow goes through. And then this is just a little pump that's injecting a small amount of hydrogen peroxide into the flow. And what happens is that this water plus hydrogen peroxide comes around over here behind all this and into this first tank up here. So in this tank, the water comes inside with the hydrogen peroxide, gets mixed through a catalyst, and it removes a lot of things that are dissolved in the water. So we've gotten all the particulates out, but there are still things like iron and manganese and a little bit of hydrogen sulfide dissolved in the water. None of it's going to hurt you or kill you, but it just kind of makes it taste and not smell so great. So all those extra things get removed in this tank. Then it comes out of this one, which is kind of a standard water softener. So you can see these bags of salt and the salt tank over there. So in here it just gets softened, and then it makes its final trip out through these valves on the floor, kind of like the irrigation, and it goes out to the different places throughout the property. So, you know, it ended up with quite a bit of plumbing work in here. Again, it's part of the sort of proof of concept, gives us a chance to do some of this stuff that we haven't done before, get to take advantage of having much cleaner, nicer water than without it, and we get to use it in the short and long term. All right, so that about wraps it up for this video. We hope you enjoyed the tour of our world's nicest shed, aka the pump house. If you got any questions about the products we used or why we did things a certain way, leave us a comment and we'll see you on the next one.